Hey everybody, this is the lesson for 4.2, section 4.2. So, 4.1 was all about classifying triangles. We learned about all different types of triangles and how we classify them by angles and sides. What 4.2 is all about what we can figure out of angles of a triangle. Alright, so that's what we'll get into. We're talking about mainly three main theorems. The first one that we're talking about is what's called angle sum theorem. What that just means, what's given here first on your notes, it says that the sum of the measures of the angles of a triangle is 180 degrees. So no matter what triangle you make, doesn't matter the shape of it, that is not a triangle. What is that? There we go. All three of those angles added up together would give us a triangle. Alright, so that's what that kind of just tells us. So, knowing that, we can figure out missing angle measurements. So that's what this first problem is. Alright, it says find the value of x, y, and z by applying the angle sum theorem. Alright, so we need to figure out all three of these angles. You're thinking, how could we ever find that? We can do that if we look at these angles and look at the bigger triangles. Alright, so what we're going to start with is we're going to get this one first. So if you look at this triangle that's colored in red here, we have three angles, x, 99, and 47. Alright, remember angle sum theorem tells us that those three angles added up together will give us 180. Alright, so this is what you would do. You'd set it up, add those three angles together, and solve for x, and we figure out x equals 34. Alright, so that's one answer. Figure out x equals 34. And then to solve for y, we would look at this triangle that's now highlighted in red. Remember, those three angles added up together would equal 180. And there's the work. Solve for y, and you figure out y is 30 degrees. Alright, and then last, you got to figure out what z is. So we just figured out that x is 30, right? 30, and then y. What was y? Y was, wait. Oh, whoops, my bad. X is actually 34 and y is 30 degrees. Alright, so add those up together and you get 68, and then whatever is left over to get to 180 will give us what angle z is. We figure out angle z is 116. Alright, so that's kind of how you would do a problem like that. Split it up into different triangles, and then knowing that all angles of a triangle add up to 180, you can figure out a lot of things knowing that. Alright, so next theorem, we have what's called the third angle theorem. And what that just tells us right here. So if we have two different triangles, let's look at these two different triangles. I'm going to label this as A, B, C, and E, D, F. Alright, so if we have these two triangles and we're given that these angles in blue are congruent to each other, and then the angles in red are the same, what the third angle theorem tells us is that we can then conclude that, let's do this in purple, that these angles would be the same. Alright, that's what's called the third angle theorem. If you have two triangles next to each other and you know that two of those angles are the same, we can conclude that the third angle is the same. Because remember, all triangles need to add up to 180 degrees. Alright, so that's that second theorem that we're looking at. The third theorem is what's called the exterior angle theorem. And what that is, if you look at this kind of figure right here, these inside angles of the triangle, think inside the triangle, we call them interior angles. Alright, so then the opposite is what's called an exterior angle. Alright, it's the angle that forms that linear pair outside. So, like this angle here would be an example of an exterior angle. This right here is another example of an exterior angle. Alright, it's an angle that creates kind of a linear pair with those angles that are inside of a triangle. Alright, so we can actually, if we know some information about exterior angles, we can solve for angles that are inside. Alright, and what exterior angle theorem tells us is the measure of an exterior angle of a triangle is equal to the sum of the measure of the two remote interior angles. So that tells us I'm just going to say angle 1, or this angle right here, equals angle 2 plus angle 3. Alright, so, and this is according to this figure here. Alright, if you look at that figure, angle 1 is equivalent to angle 2 plus angle 3. Remote interior, that just means the interior angles that are opposite of that angle right there that we're given, that exterior angle. Alright, so that's what exterior angle theorem is. So there's that. And then next, we are going to be solving for a bunch of missing angle measurements. So, what we're going to start with, we're just going to go in order of numbers here. We got to figure out what angle 1 is. Alright, and we're actually just going to use the exterior angle theorem that we just talked about. Alright, so remember what exterior angle theorem tells us is that that exterior angle is going to be equivalent to this angle plus this angle. Alright, so I'm going to say angle 1 equals 86 plus 40, or 126 degrees. Alright, so I'm going to fill that in, 126. Then, if I know that angle 1 is 126, and since this is a straight line, that would mean angle 2 is the supplementary angle to 126. Alright, so to figure that out, you would just go 180 minus 126, and you figure out that angle 2 is 54 degrees. Alright, and then also in 4.1, I don't remember if I mentioned it or not. I don't know if I did. But if you have an isosceles triangle, remember those tick marks tell us that those sides are the same. But another thing to keep in mind, if you have an isosceles triangle, that means that the angles that kind of line up with the isosceles sides are the same. Alright? Yeah, so angle 2 and angle 4 are the same because we know that they are isosceles. So angle 3 we don't know yet. Angle 4, you know, since it's an isosceles triangle, that angle 4 is also going to be 54 degrees. Alright, and then, let's see. Since we know that angle 2 and angle 4 are both 54, that means, remember, all three of these angles added up together give us 180. So you would go 54 plus 54, which is 108. And to figure out that angle 3, we just go 180 minus 108 to figure out that angle 3 is 72 degrees. Alright, so this is kind of a loaded question. It's dealing with a lot of different things. So to get angle 5, alright, to get angle 5, since I know angle 4 is 52 degrees, 54 degrees, I also know angle 5 is also 54 degrees. And why is that? Because these angles I filled in there are what's called vertical angles. Remember, vertical angles are always the same. Alright, then the last, we got to figure out angle 6. I'm going to use exterior angle theorem. Again, what that tells us is that 115 is equivalent to angle 5 plus angle 6 added up together. Alright, and since I know angle 5 is 54 degrees, that means angle 6 would just be 115 minus 54, which would give us an answer of 61 degrees. Alright, so that's kind of how you would do that problem. You just have to use all three of those theorems when figuring this out. Alright, the majority of those problems you can figure out if once you get down that all angles of a triangle add up to 180. Alright, that's used a lot in geometry, especially this chapter. Alright, next we have what's called some corollaries. Corollaries is just kind of a fact, something we know about geometry. It's similar to, think of like a postulate. Remember when we talked about those with proofs? It's just a mathematical statement, alright, or in geometry a statement that we can use that is proven. Alright, so what 4.1 tells us is the acute angles of a right triangle are complementary. Since I know if I look at a right triangle, if this is 90 degrees, that means this angle plus this angle would also add up together equal 90 degrees. because they have to equal 180. Then what theorem 4. What corollary 4.2 tells us is that for any triangle, there can be at most one right angle or one obtuse angle. Alright, you can't have two obtuse angles, because then the angle measurement would be more than 180. We can't do that. Also, you can't have more than one right angle. Alright, otherwise the angle sum would be over 180 degrees. We can't be doing that. Alright, so that's what those two corollaries are. Just things to keep in mind. Last, we have a word problem. It tells us a windsurfing sail is generally a right triangle. I'm going to draw a picture. Always draw a picture for these types of questions. Alright, if it doesn't give you a picture, always draw a picture. It says one of the angles that is not the right angle is 68 degrees. This one looks like it's 68 degrees. What is the measure of the other non-right angle? Alright, so since I know that these three angles added up together will give us 180, I'm going to say this is x. I would just go 90 plus 68 plus x equals 180. Since I know those three angles added up together give us 180, we would just solve for x there. Alright, combine those to get 158 plus x equals 180, and then we solve for x. We figure out x is 22 degrees. Look at that, nice oval. Nice. Alright, so that's the answer, 22 degrees. Alright, big theme from 4.2 to remember, angles of a triangle all add up to 180. Big thing to keep in mind. Alright, thanks for listening, thanks for watching, and let me know if you have any questions, and I will talk to you later. Peace.